Okay, we are doing the examples for section 4.6, and this time we're going to be graphing tangent and our reciprocal functions. So we have our first example up here of y equals 2 tangent of 3 to the x minus pi plus 1. Now the first thing is, just like with sine and cosine in all of our transformations, we have to factor out that 3. So if I factor that out, I get y equals 2 tan 3 to the x minus pi over 3 plus 1. Now with these problems, you are going to be having a lot of fractions, so we need to make some space for ourselves. Also, with tangent, we're going to use a little bit different numbers than we have in the past. So our mother function values are, we are going to start at negative pi over 2 because we want to stay centered around our origin. So negative pi over 2, tangent is undefined. Remember, tangent is sine over cosine, and at negative pi over 2, cosine is 0. So we have a 0 in our denominator there. At negative pi over 4, we're at negative 1. At 0, we are at 0. Pi over 4 is 1. And at pi over 2, we're back to undefined. So what that means is we're going to have some asymptotes with this. So we've added another little element to tangent and cotangent, as well as the reciprocals. They all have asymptotes. Okay. So that's our mother function. So now let's start doing our transformation. So the first thing I want to do, and I want to give myself plenty of room, is I'm going to divide my fraction by my b value. So negative pi over 2 divided by 3. Well, dividing by 3 is the same as multiplying by 1/3. So that's negative pi over 2 times 1/3 . And that's actually negative pi over 6. And I'm actually going to put that way over here. Okay, so there's my negative pi over 6. So instead of writing divided by 3 from now on, I'm just going to say I'm multiplying by 1/3. So negative pi over 4 times 1/3, negative pi over 12. 0 times 1/3 is just 0. Pi over 4 times 1/3 is pi over 12. Pi over 2 times 1/3 is pi over 6. Okay? Alright, so I have my first x values. Now let's find my y values. If my function was undefined to start, it doesn't matter what I multiply by it or add or subtract to it. It's still going to be undefined. So this first y value is undefined. Now take negative 1 times our 2, and that gives me negative 2. 0 times 2 is 0. 1 times 2 is 2. And we're back to undefined. So it's still undefined. Now let's do our other table, our last one. And I'm actually going to change colors so that we can kind of differentiate. And I'm definitely going to give myself room, because for my x values, I have to find a common denominator, because I'll be adding and subtracting. Y values, I don't need that much space. Alright, so now I'm going to have x divided by b plus whatever my c is. So I have negative pi over 6 plus pi over 3. Common denominator is 6. So negative pi over 6 plus 2 pi over 6 And that gives me just a pi over 6. So my final result is pi over 6. Next one, negative pi over 12 plus pi over 3 equals, common denominator is going to be negative pi over 12. So I'm going to change the 3 to a denominator of 4, or denominator of 12 by multiplying by 4, I'm sorry. Combine like terms and I get 3 pi over 12. I do not want to reduce that yet. Same as with when we were doing sine and cosine, we want to kind of see what our scale is. And so 12 might be what I want to change all my denominators to. The next one, 0 plus pi over 3 is just pi over 3. And if I want to go with that denominator of 12, that would be 4 pi over 12. Here, pi over 12 plus pi over 3. That's going to be pi over 12 plus 4 pi over 12. And that's going to be 5 pi over 12. And the last one, pi over 6 plus pi over 3. Common denominator, since we've already got so many 12s, I'm probably just going to change everything to a 12, so I'm just going to do that here. It'll help when we go to scale of where everything's at. So pi over 6 is 2 pi over 12. Pi over 3 will be 4 pi over 12. Together that gives me 6 pi over 12. Okay, so there's my final x values. And again, it's just working with your fractions. You're going to have to practice working with your fractions. Now my y values. A times y plus d. Again, if it's undefined here, it's still undefined. Negative 2 plus 1 is negative 1. 0 plus 1 is 1. 2 plus 1 is 3. Undefined, it's undefined. Alright, so let's sketch our graph. Let me get a ruler. So I have all these 12s, so I want to count by 12s. Now the first one I didn't change, it was a pi over 6, so pi over 6 is 2 pi over 12. So let's make our graph. So this is pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, and so forth. I'm just going to keep going as far as I need to go. Alright? Now, going vertically, I'm going to count by ones. So this is 1, 2, 3, and this is negative 1. So now let's graph this. So at 2 pi over 12, which was where our pi over 6 was, we're undefined. So we have an asymptote there. So you make your asymptote. Remember, it's a dashed line. Okay. Then our points are at 3 pi over 12, negative 1. So 3 pi over 12, negative 1. 4 pi over 12, 1. 5 pi over 12, 3. And you're only going to have 3 points with tangent. You're actually only going to plot 3 points. And then we're back to being undefined. And that's at 6 over 12. made my x-axis a little too long, but that's okay. Now to sketch your graph, it's not a straight line, it is a curve. So it comes up the asymptote, curves into the first point, keeps going, curves into the second, third, and so forth. Okay? And that's what a tangent graph looks like. And it just keeps repeating this same pattern. So now let's do our laundry list. So let's talk about our amplitude. Tangent doesn't have an amplitude. Okay, tangent does not have an amplitude. Please don't give it one. So amplitude for tangent does not exist. The period. Because we didn't go all the way around the circle, we only went halfway around it. The period for tangent is pi. So to calculate our period, we take pi divided by b. Well, in this case, b was 3, so it's pi over 3. Our phase shift. That's our c value. We move to the right, pi over 3. Our amplitude, we moved up 1. Now let's talk about our domain. Okay, so unlike sine and cosine, tangent's domain is not all real numbers because it does have these undefined values. And you're going to notice that these undefined values happen a certain distance apart. And that distance is your period. So what we're going to do is, our domain is all real numbers, except x cannot equal, we start with the first one, so 2 to pi over 12 is pi over 6. In your list of information, you do have to reduce your numbers. Pi over 6 plus and minus that distance of your period, pi over 3. This is going to take out every value where tangent is undefined. Our range. Every y value, so all real numbers. And the last thing is asymptotes. Okay, so my first asymptote is at pi over 6. So x is equal to pi over 6. But then it repeats itself every period. And you have to also remember it goes in the other direction. We could have gone clockwise around our circle. So plus or minus the period n. And that's how I forgot to put that up here as well. The n gives us our revolutions, the multiple times around the circle. Okay, so that's example 1. It does not have a max or min. Again, it does not have an amplitude. Okay, let's go on to example 2. Okay, example 2 is a cosecant graph. Y equal to, -2 cosecant of 2x minus pi over 4 minus 1. going to do is we're going to take out our b value. And so y equals negative 2 cosecant of 2 to the x minus pi over 8 minus 1. Now, remember, cosecant is the reciprocal of sine. So the easiest way to graph this is, rather than trying to actually plot the cosecant graph, we're going to plot sine. So we're going to pretend that this is a sine graph. So we're going to pretend that our graph is actually this. And the reason we're doing it is because the only difference between the cosecant graph and the sine graph is that the value is the reciprocal. The angle stays the same, it's just that the y value is going to flip over. And rather than trying to remember to flip every single y, we have a little trick that we're going to use. Okay? So we're going to graph this sine graph. So let's start with our table. And you might want to get a second color, because we're going to use two different colors for our graphs. So this is for y equals the sine of x. We're going to use those points. So at 0, sine is 0. Pi over 2, sine is 1. At pi, sine is 0. 3 pi over 2, sine is negative 1. 2 pi, we're back to 0. We're going to do the transformation as if it's a sine graph. Just want to make sure that you're really clear with that. So now let's do our points. So I'm going to divide it by 2, all my x values, but dividing by 2 is the same as multiplying by 1/2. So 0, 0. 0 divided by 2 is just 0. That one's easy. Pi over 2 divided by 1/2 is the same as multiplying by 1, or dividing by 2 is the same as multiplying by 1/2. And that gives me pi over 4. Pi times 1/2 is pi over 2. 3 pi over 2 times 1/2 is 3 pi over 4. 2 pi times 1/2 is just pi. Now for my y values, a times y. My a is 0, or excuse me, my y is 0 times negative 2 is 0. 1 times negative 2, negative 2. 0 times negative 2 is 0. Negative 1 times negative 2 is positive 2. And 0 times negative 2 is 0. Okay. So again, at this, it's still not, we're just doing what we did last class. Just doing exactly the same thing. Last table. And again, you want to give yourself room because you are working with your fractions. Just to make sure that you can get all the addition and stuff in. So it's x divided by b plus my c. So that's 0, and my c is pi over 8 plus pi over 8. That gives me pi over 8. Pi over 4 plus pi over 8. Common denominator is going to be 8. And that's going to equal 3 pi over 8. Pi over 2 plus pi over 8. Common denominator is 8 again. So that's 4 pi over 8 plus 1 pi over 8. And that's 5 pi over 8. 3 pi over 4 plus pi over 8. That's 6 pi over 8 plus 1 pi over 8. That gives me 7 pi over 8. Pi plus pi over 8, that's 8 pi over 8 plus 1 pi over 8 equals 9 pi over 8. Now here's something you should notice. This was a 1 over 8, this is 3 over 8, this is 5 over 8, 7 over 8, 9 over 8. It's increasing by 2. You need to make sure your values increase or decrease by the same amount. It's a pattern. It follows a certain pattern. And now let's do our y values. So 0 minus 1 is negative 1. Negative 2 minus 1 is negative 3. 0 minus 1 is negative 1. 2 minus 1 is 1. 0 minus 1 is negative 1. Again, sign, remember the first, the third, and the fifth all match. Alright, now let's graph this. And I'm going to use two colors that are easy to see. I'm going to use black and I'm going to use red. The black I'm going to do is the sine graph, and then I'm going to show you what to do in red to find the cosecant. Okay, so for my x-axis, all of the denominators are 8, so I'm going to count by eighths. So this is pi over 8, 2 pi over 8, 3 pi over 8, and you know what? Oh, I'll keep going. 4 pi over 8, 5 pi over 8, 8, and 9. Okay? We could have counted every other one, as long as you keep your scale consistent. 1, 2, 1, negative 1, negative 2, negative 3. Okay, so we're going to plot this like it's normal. So at pi over 8, I'm going to go to negative 1. 3 pi over 8, negative 3. 5 pi over 8, negative 1. 7 pi over 8, 1. 9 pi over 8, negative 1. And I'm just going to lightly sketch it in. I don't want to do it too dark, because this is not the graph we want to end up with. Okay. Alright, so here's what happens. If you remember back that sine is the reciprocal, or cosecant is the reciprocal of sine. So all of these values where sine was 0, they're going to flip over and 0 is now going to be in the denominator. So they're going to be undefined. So where all my zeros were, here, are my undefined values. Alright, these are my undefined values. My undefined values means, and it doesn't matter that there's numbers here, okay? It just continues all the way through. These are where my asymptotes are going to be. So every place that there's my zeros, right here and here, I'm going to put an asymptote. So I'm going to sketch in an asymptote right through those points. And you're going to have 3 when you graph each of these, because you're going to have 2 on the ends and then 1 in the middle. Now here's what we're going to do. We are going to rip it, well, we have already ripped it, and we're going to flip it. So these rips are where the zeros were. We've just broken this graph into two separate graphs. Now, all these values that were going up, well, we flip it over. So now they are going down. All these values that were going down, they are now going up. Our red graph is our cosecant graph. So the black graph there, we're not even going to really look at. We're going to look at these ones, our red. And now let's fill out our list on it. So the period. The period for the cosecant graph is the same as the sine graph. And it's found by taking 2 pi divided by our b value, which is 2. So our period is pi. Amplitude. All of our reciprocal functions, just like tangent, have no amplitude, so it does not exist. So the only thing that has amplitude is sine and cosine. Everything else does not have an amplitude. Our phase shift. That is our C value. So it's to the right, pi over 8. Our vertical shift is down 1. Okay? So that's the basics for the trig. Now let's talk about our domain. Our domain is similar to tangent in the fact it's all real numbers, but we have to take out our asymptotes. So it's all real numbers. X cannot be, and you start with the first one, which is pi over 8, plus or minus, how far apart is pi over 8 from 5 pi over 8? Subtract them. 5 pi over 8 minus pi over 8 is 4 pi over 8, and that reduces to be pi over 2, n. So half the length of the period. That's another way of saying it. So if you divide your period by 2, that's what you're going to have here. So it's a little different than tangent in the fact that tangent, it was the same as the period. Here it's half. My range, it goes from negative infinity to this point right here, which is a relative max. So let me actually, I'm going to put that here. This is a relative max. So it goes from negative infinity to negative 3. And then it jumps all the way up here to 1 to infinity. Well, it would make this 1, this point right here, a relative min. Okay, real quick. Students get these mixed up because this is at the top of the graph. It's the upper parabola. They think it's a relative max. Be careful. Students a lot of times will reverse these. They'll call this a max and this one the min. It's not. So pay attention. Okay, so my asymptotes. My asymptotes are where my x values don't exist. So it's kind of already right here. So I just have to say x, where x equals pi over 8 plus or minus pi over 2 n. It's quick and simple. The last thing we're going to talk about with this one is relative max and min. And relative min. We have those with this graph, so we're going to include them. Well, my max is at 3 pi over 8 comma negative 3. But that's going to repeat every period. So I need to include the other x values. The y value is always going to be negative 3. But as I go around that circle, and every time I hit 3 pi over 8, I'm going to have a max. So it's 3 pi over 8 plus or minus my period times the number of revolutions I go, comma, negative 3. Now do the same thing for the min. My min is at 7 pi over 8 plus or minus pi n, but this time my y is 1. Okay, that's it for this example. Let's go on to the third one. Y equals negative secant of 1/2 x plus 3 pi plus 1. Okay? Again, we're going to do this very similar to the way we just did the previous example, but now instead of secant, instead of sine, we're using cosine. Same thing. We're going to factor out the 1/2. Factoring out that 1/2 is the same as multiplying by 2. So that's going to make that a 6 pi plus 1. Okay? So again, we're going to pretend that this is y equals negative cosine of 1/2 x plus 6 pi plus 1. We're going to graph that one, and then we're going to rip it and flip it. Okay, so let's make our tables. So cosine starts at 0, but the y is at 1. Pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi back to 1. Okay, so let's start doing our transformation. So I'm going to take x divided by v. So I'm going to divide by 1/2. But that's the same as multiplying by 2, so I'm just going to multiply everything by 2. So pi over 2 times 2 is just pi. Pi times 2 is 2 pi. 3 pi over 2 times 2 is 3 pi. And 2 pi times 2 is 4 pi. That's going to make things nice. We have no more fractions. Woohoo! No fractions. A times y. So 1 times negative 1 is negative 1. 0 times negative 1 is 0. Negative 1 times negative 1 is 1. 0 times negative 1 is 0. And 1 times negative 1 is negative 1. Okay. Now our last table. I don't have to make it as big because I don't have the fractions. X divided by b plus c. So I have 0. Now this is a negative 6 pi. Remember, you have to change the sign. So minus 6 pi is negative 6 pi. Pi minus 6 pi is going to be negative 5 pi. 2 pi minus 6 pi, negative 4 pi. 3 pi minus 6 pi, negative 3 pi. 4 pi minus 6 pi, negative 2 pi. Okay, so our whole graph's going to be over on the negative side of our axis. Now do the last a times y plus d. So negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 0 plus 1 is 1. Negative 1 plus 1 is 0. Alright, so there's our final points. Let's graph this. I don't need no. Oh, that's good English. Alright, I don't need any positive x's, so I could just move my x-axis way over to the right. And so I'm going to count by pi, so this is negative pi, negative 2 pi, negative 3 pi. And this is going to be 1, 2, oh that's a bad place, 2, and this will be negative 1. Okay, so let's plot our points as we normally would. So at negative 6 pi, I am at 0. Negative 5 pi, I'm at 1. Negative 4 pi, I'm at 2. Negative 3 pi, I'm back to 1. And negative 2 pi, I'm at 0. Okay. Alright, you get the idea. Alright, so there's my cosine graph, but I don't want my cosine graph. I want my secant. So find where my zeros were. My zeros were at the 2nd and the 4th. So that's these 2 points right here. So I'm going to highlight those. This is where my asymptotes are. So I'm going to use my red pen again, and I'm going to make my asymptotes. I'm going to rip this graph right here. Here, and right here. Now the same thing happens. Where this was curving up, this is curving down. Where this was curving down, it's going to curve up. Where this was curving basically up towards here, it's going to curve down. So the secant graph is kind of disjointed a little bit. It's got one whole parabola up here, and then the other two are kind of split in half. And that's okay. That's okay. So now let's do our laundry list. Let's do our amplitude. Hey, I just told you something in the last example. Cosecant have an amplitude? Nope. Does secant? Nope. Does cotangent? Nope. Does tangent? Nope. None of them have one. So it does not exist. Doesn't have one. Or NA. Doesn't have one. Okay. Period. Found the same way as we do for cosine. It's 2 pi divided by b. Well, 2 pi divided by 1/2. Flip it over, change it to multiply, and it becomes 4 pi. Phase shift. Phase shift, it's moving it to the left. 6 pi. Vertical shift is up 1. Domain, do it the same way we did the cosecant graph. We're going to have all our x values except where our asymptotes occur. And it doesn't matter which one you use. It doesn't matter. You could use the negative 5 pi or you could use negative 3 pi. Doesn't matter. It's all real numbers except x cannot equal negative 5 pi plus or minus. How far apart are these? The distance between negative 5 pi and negative 3 pi is 2 pi. or half your period, n. So there's my domain. My range, do it the same way as the cosecant graph. It's going to go from negative infinity up to our maxes. So this is our max. That's a relative max right there. So it's going to go from negative infinity up to 0. And then our min is here at 2 to infinity. Okay. Our asymptotes. Helps to spell it right. Asymptotes are in the same places where x can occur, and that is right here. So I'm just going to say x equals negative 5 pi plus or minus 2 pi n. And again, n is the number of revolutions around the circle. Relative max. My point is at negative 6 pi. And it's again over here at negative 4, or negative 2 pi. They have a distance of our period of 4. Comma, 0. And our relative min is right here at negative 4 pi. Plus or minus 4 pi n, comma, 2. Okay? Questions? Make sure you bring them to class. This is the last of the examples for 4.5 or 4.6. Again, basically with these graphs, most of them you're going to be ripping and flipping them. That makes the difficult part. You're going to graph them as if they were sine or cosine. Even the cotangent, you're going to rip it and flip it. You're going to rip that tangent graph and flip it.